Welcome to Physics Made Easy channel. We were doing photoelectric effect, and now in my last lecture we have just gone through a few points of the laws of photoelectric emission. And now first I will go through the failure of classical wave theory, and then we shall be proceeding to photoelectric equation, on which Nobel Prize was given to Albert Einstein. Now the important point is that first we were to recap. First I will go through the laws of photoelectric emission for given metal. Now simple, for given metal, if the frequency, the condition is if the frequency is above the threshold frequency. First condition is, all right, if the incident frequency, nu I is greater than threshold frequency nu naught, then photoelectric current is directly proportional to I. And corresponding to this, I will remind you this diagram. This is the diagram corresponding to it. We have done it. This is a graph corresponding to it. If intensity increases, photocurrent increases. So again recapping this from here. Now the condition is that incident frequency, or the frequency of the incident radiation, should be greater than the threshold frequency nu naught. If this condition is satisfied, then photoelectric current, this small I represents photoelectric current, is directly proportional to intensity. Intensity is represented by capital I. So we have mathematically expressed first law of photoelectric emission. In second law of photoelectric emission, there is minimum cutoff frequency of a photosensitive material, which may be different for different materials. And there is a graph for this. For example, this is the minimum cutoff frequency for, you can say, metal A, and stopping potential for this is 0. And this is the minimum cutoff frequency for metal B, and stopping potential for this is 0. It means there is a minimum cutoff frequency if radiation is incident with a frequency lesser than that threshold frequency, then no photoelectric takes place. This is reflected by 0 value of the stopping potential in this graph. And now now another important point. If the incident frequency is less than the threshold frequency, I will write it here. What this says, I will write it in mathematical language of mathematics. If there exists a minimum frequency nu naught. Now if incident frequency is less than threshold frequency, then whatever may be the value of I, it means if you keep incident frequency lesser than the threshold frequency, then go on rising the value, go on making the value of intensity high. Even if you raise the intensity level, no photoelectric emission will take place. This fact is in violation to the classical theory. Again listen, if there exists threshold frequency, if incident frequency is lesser than the threshold frequency, then you cannot make photoelectric happen by raising the value of intensity of light. Now go on raising this, photoelectric effect will not take place. Occurrence of photoelectric effect is independent of the value of intensity, provided it should be more than 0. Only condition for the occurrence of photoelectric effect is that the value of incident intensity should be greater than, this is the condition for photoelectric effect to take place, the value of incident frequency should be greater than that of the threshold frequency. I shall be picking up this point in classical theory immediately. And now, third, for frequencies more than threshold frequencies. Now, the first condition is frequency should be more than threshold frequency. In that case, stopping potential is directly proportional to incident frequency. Now, what does this mean? This is Km. Now, stopping potential, we can also write here Vs, but we have chosen Km here. This is Km. It means Km is directly proportional to incident frequency if incident frequency is larger than threshold frequency. Now, instead of this, I can also write stopping potential. Stopping potential is directly proportional to incident frequency if incident frequency is larger than threshold frequency, and it's an instantaneous process. This point was not explained by classical mechanics. And point number 2, classical mechanics is in contradiction with point number 2 and 4. How? Now I will recall you electromagnetic wave theory. We shall be going through failure of classical mechanics. Why did classical mechanics fail here? Classical wave theory. Classical wave theory. One is the classical wave theory which we study in mechanics, that light travels due to the vibration of medium particle. That failed to explain propagation of light, particularly velocity of light, and they gave a very hypothetical concept of ether medium, which later on was found to be not to be correct. So mechanical wave theory failed to explain the behavior of light. Now, electromagnetic wave theory was successful in explaining the behavior of light. Or in that case, we assume light to be of electromagnetic nature. And there is electric vector and magnetic vector. Electric vector vibrates in, I will recall you actually I need a diagram here, so I'm and now this is that diagram. This is electromagnetic wave theory. What electromagnetic wave theory says that electric and magnetic vectors, they are perpendicular to each other, and in turn they are perpendicular to the direction of propagation. So this is the famous relationship S is equal to E cross B. We have done it already, and electric vector is much more powerful than magnetic vector. So I have represented these direction along x-axis. Light wave travels, along y-axis are the vibrations of electric vector, and along z-axis there are the vibration of magnetic vector. Red color, the wave shown in red color is electric vector. The wave shown in blue color is magnetic vector. So this is basic representation of an electromagnetic wave, and it gives a three-dimensional sense. That's why I have particularly selected this diagram. Now, from this, we have calculated the formula for energy density epsilon naught E square. This is intensity I by C, and then intensity I is U into C. Energy density, energy radiated per unit volume per unit time. This is how we defined energy density. Now, In this case, greater the intensity of radiation means greater energy. Note this case. Intensity or energy density, if I write here, energy density U is directly proportional to I. It means greater the intensity, greater will be the energy density. So what they expected, that kinetic energy from this relationship, they expected that in photoelectric effect, kinetic energy of the emitted electron, I will write it by K. Kinetic energy is directly proportional to intensity. This gives us this sense. This is what was predicted by classical mechanics. But we have noticed that kinetic, according to quantum mechanics or according to laws of photoelectric emission, kinetic energy is directly proportional to frequency and not intensity. So here, according to classical mechanics, so this was expected, which was found to be wrong. So that's why classical theory fails to explain photoelectric effect. I will further elaborate it. Greater the intensity of incident radiation means greater energy density of wave. Kinetic energy of electron emitted will be directly proportional to intensity. This is what it predicted. But this was contrary to the experimental result. This was proved to be wrong by the experimental results, which says that I have just stated, experiments states that kinetic energy K is directly proportional to incident frequency, provided incident frequency is larger than threshold frequency. So this was predicted by classical theory, which have been proved wrong by experimental observation. Now, the second thing which classical theory fails to explain. No matter what, now he says that photoelectric effect is independent of incident radiation, particularly the frequency. How? Now what this photoelectric effect says, you could have done at in your lower classes. If you take a convex lens and take a piece of paper, now keep on focusing light on the piece of paper. After some time, piece of paper will start burning. If the converging power of lens is more, then it will take lesser time. What classical mechanics says, just filling of glass with water. Now, you slowly pour water in glass, level will keep on rising, and at one particular level water will start spilling out of the glass. So this is what classical mechanics says. If the intensity of incident light is dim, then photoelectric effect will take after a long time. Now, if the intensity of incident radiation is high, then photoelectric effect may take place immediately. Now, classical mechanics says that the photoelectric effect depends upon intensity. The quickness with which photoelectric effect will take place depends upon intensity, and photoelectric effect may be an instantaneous process or it may be a delayed process, which was not supported by experimental observation. Experimental observation says that photoelectric effect is an instantaneous process. Once the light frequency falls, within nanoseconds, photoelectric effect takes place. There is no time lag between the incident of light radiation and emission of photoelectrons. Now, first fact, kinetic energy directly proportional to intensity has been violated. Second fact, that kinetic energy directly proportional, it has been proved wrong. And then frequency, classical mechanics says no threshold frequency exists, but experiment says threshold frequency exists. And the last point is the energy of light wave is smoothly and evenly distributed in advancing wavefront. Each electron intercepts an insignificantly small amount of the energy. So it would require finite time to escape from the metal. Just for example, you need phi. For example, cesium is the metal. For cesium metal, you just need 2.4 electron volt to escape from the surface. Suppose electron gets 0.1 or 0.2 electron volt in 1 second. An electron gets 0.2 electron volts in 1 second. What classical theory says? Classical theory says that in 1 second it will take 0.2 electron volt, in 2 seconds 0.4, in 5 seconds 1 electron volt, in 10 seconds it will get 2 electron volts, and in 12 seconds it will get 2.4 electron volt and it will get emitted. Classical mechanics says that electron will keep on storing energy as it falls on the electron. So it will keep on storing some part and go on adding up, and then ultimately once it reaches 2.4 electron volt, or the work function, once the assimilated energy is equal to, or the acquired energy is equal to the work function, emission will take place. It means after how much time emission will take place, that depends on the energy stored by the electron that it got from the incident radiation. So this was the concept of wave theory, and it has been rightly observed. As I have just given you an example, you can experiment it. Take a convex lens and made the incident light focus on one particular spot of the paper, and after some time it will start burning. What this means, that the spot on which the light was focused, its temperature go on rising. Once its temperature reaches the burning point, it starts burning. But this does not take place in case of photoelectric effect. In photoelectric effect, it's a all or nothing process. First of all, light is made up of photon, and electron photon interaction is like this. Either whole of the photon will be taken up by the electron, or it will not be taken up at all. It is all or nothing process. So even this has been found to be experimentally wrong. Why? Because photoelectric effect is instantaneous process. So I have explained in detail the failure of classical theory. First, failure to explain the existence of threshold frequency. Second, failure to explain the dependence of kinetic energy on frequency. Rather, it was saying that kinetic energy depends upon intensity. Failure to explain dependence of kinetic energy on frequency. Failure to explain existence of threshold frequency. Failure to explain the instantaneous process of photoelectric emission. It was saying that it may be instantaneous, may be delayed one. Now, this is the famous Einstein equation known as photoelectric equation. Important points for photoelectric equation are: first point, photoelectric emission is the result of interaction, photoelectric emission is the result of interaction of incident photon and bound electron of metal. Bound electron means we need some energy to make electron free from metal surface. This electron is not bound with the nuclei. Kindly note this fact. The energy needed to free an electron bounded by nuclei is called ionization energy. Listen again. The energy needed to free an electron from nuclei of an atom is called ionization energy, and the energy needed to make an electron free from the metal surface is called work function. The minimum energy required to make a bound electron free from the metal surface is called work function. So we have explained work function of metal. So this is the minimum energy required. Each photon interacts with one electron. This is one-to-one interaction. The energy h nu of the incident photon is used up in two processes. First, some part of the energy is used to supply work function or to make the electron free from the metal surface. First part. Remaining part of the energy is used for imparting kinetic energy. Now, so I will just write from Planck's law of radiation, E is h nu. Now, in my previous article, I have proved that phi is equal to h nu naught. How? First of all, as per the statement, energy E, I will write it as equation 1. Energy is consumed for two parts. One part is for providing work function. Another part is for providing kinetic energy. Now, this work function we don't know. This is phi. Plus this kinetic energy, I will write it as half mv square. I will take the formula from mechanics, and this is this. And now, we will use one thing. Put v is equal to 0. If v is put equal to 0, then work function at 0. So if v is 0, I will put nu equal to threshold frequency, nu naught, and phi equal to phi naught, which is work function, which is purely work function. Now, if we put these values in this equation, equation 2 becomes, h nu naught is equal to phi naught plus 0. This implies phi or phi naught, I have written it by phi naught, is equal to h nu 0. You can even just write phi. So, I shall be using value in equation 2. Now, use 3 in equation 2. So, what I will get is h nu is equal to h nu naught. Now I will write here kinetic energy by K max. Now K max, Km is equal to h nu minus nu naught. This is famous Einstein's equation. This is famous Einstein's equation. So this is famous Einstein's equation. Now these are two forms of Einstein's equation. The one is this, you can also write it like this, which I have written, you can also write it like this. So it's quite easy, we have just drawn this equation. So there are two forms. One form is this, that is Km, I have written it by Km, half m v max square, m square. So this is h nu minus phi naught. Phi naught is work function. Another is just you fill the value of phi naught, which is h nu naught. Now half mv x square, then this becomes this equation, which I have just written that Km is h nu minus nu naught. Now this equation fundamentally gives us the concept of threshold frequency. How? If nu is less than, now if nu is less than nu naught, then K max is negative, which is not possible. Kinetic energy cannot be negative. This means photoelectric effect does not take place. Now the first case that I will write here, if nu is larger than threshold frequency nu naught, then Km is larger than 0, which is possible, and photoelectric effect takes place. Now from these two equations, what we learned is that if the incident frequency is larger than the threshold frequency, then photoelectric effect takes place. This is the basic equation. And if the incident frequency is lesser than the threshold frequency, photoelectric effect does not take place. This has been represented here by cross. Photoelectric effect takes place represented by tick, like this. So because kinetic energy is half mv square, and it cannot be negative because mass is positive and square is always positive. So this is something unviable. The photoelectric effect does not take place if the incident frequency is lesser than the threshold frequency. It will take place if the incident frequency is larger than the threshold frequency. With these words, I have taken 5 minutes more than the usual lectures. I finish my lecture, and before finishing my lecture, I will request you that kindly go through these videos. We are working upon them. And if you find some points of improvement, then kindly inform us. And if you find them to be useful, then kindly share them. With these words, I finish this lecture, and probably in 1 or 2 days, I shall be giving you uploading a video on NCERT problems on wave optics. Believe me, whether it is board examination or JEE Main, NEET or JEE Advanced, all the questions they are asked from NCERT books. If you are thorough with NCERT and exemplar, you don't need to follow any other book. Please listen this. You follow other books only for practice, not for grabbing the basic concepts. NCERT is sufficient, is the only sufficient source for preparing for board examination as well as for other competitive examination. Taken much time. Now I finish this lecture, and we will meet in my next